We're getting to what I think is going to be one of my favorite parts of this conference, where I get to sit down with Blake Strom. So, at MITRE, we have this unique vantage point as a not-for-profit research and development organization that really helps us develop innovative solutions like ATT&CK. And you're all here because of ATT&CK. But we often get the question, so where did ATT&CK really come from? What was really behind it? How did you go from whatever you started with to what it looks like today? And so to answer those questions, I'm going to sit down with Blake Strom to talk about how we got here. So Blake is a cybersecurity researcher and engineer and is one of the original creators of the ATT&CK matrix. Today he leads MITRE's ATT&CK team, and his interests really span the whole security spectrum, from security operations, red teaming, and adversary emulation to threat hunting and automation. Prior to joining MITRE, Blake worked for the U.S. Department of Defense. So while I do not have two ferns, and I am not Zach Galifianakis, I think you will find this interesting. So please, again, welcome Blake Strom. I think everyone here is already familiar with ATT&CK. I don't think we have to belabor that. But this origin story of ATT&CK, taking form originally back in 2013 is fascinated me since I joined MITRE about a year and a half ago. So I unfortunately can't take any credit for ATT&CK. But we've seen this incredible growth, from what was 64 techniques to 223 as of yesterday, 80 adversary groups, 280 pieces of software. That's a pretty significant change. And I will also note, about this time last year, we had maybe 1,500 Twitter followers. And when I checked last night, it was 13,200. So pretty awesome. So Blake, can you tell us a little about how ATT&CK got started? What was the thought process?
Yeah, so you mentioned it really started in 2013, but the history kind of goes back a little bit further than that. So ATT&CK was really developed as a way to solve a few problems in another research project that MITRE was working on at the time called FMX. And that project started, the idea got started about 2010, and then the project really started getting going in about 2012. And the whole goal of that project was to figure out better ways of detecting adversaries after they've already gotten access to the network. So they're already moving around, trying to find their objectives, learning about the environment. And what we really wanted to do was sort of get in the head of the adversary, figure out what they're trying to do, and look for the side effects of their actions on the system. So if you think back in the 2012, 2013, a lot of organizations were basing their defensive posture on indicators of compromise or IOCs. So you think of IP addresses, domains, registry values, file hashes, strings of malware, those sorts of things. But those are very fragile over time. So adversaries are very adept at changing, modifying those things so that one intrusion might use one set of IOCs, and then an adversary would go attack another organization and use a completely different set of IOCs, because they were very much aware of how information was getting shared between organizations. And even recently, some of the folks at FireEye and Mandiant have said that they've seen intrusions where adversaries are actually using different IOCs per system. So it's hard to share information. It's hard to even find other infected systems in one network during an incident if you're just basing it on IOCs. So our goal with FMX was to figure out what are additional data sources that we can use, what sort of information can we collect to help look for that adversary's behavior on the system. And not necessarily focus on their tools or their operational infrastructure. Because it's really sort of the difference between looking for an intruder's physical fingerprints during maybe a burglary or something. You'll see sort of what they were going after, what they touched, and stuff like that. But what we're trying to do is sort of figure out, what are adversaries going to go after, how are they going to go after it, so we can set up, cameras to look for that behavior as they're doing it in the act.
So that sounds simple in theory, but in practice, how did you actually do that?
So going back to the FMX research project, We had basically a defense team and an offense team. The defenders were researching new sensors, so different ways to collect data. They were piping that data back into an analytic repository. We were using Splunk at the time, and then generating analytics based on their hypothesis of what they thought adversaries were going to do. And then we had the red team actually inject those behaviors in a production network to figure out, is this actually working? So at the time, when things were getting going, the red team was driving a lot of the scenarios that were being developed. So they had many years of experience breaking into networks, and they had their own sort of way of doing things. And we had some idea of common commands that adversaries would use at the time. So like ping-1 for system discovery, looking to make sure that a system was live and running, various net use commands for discovering information. We would pepper those commands within the scenarios that were being developed, but it wasn't really a good structured way. It wasn't really all that repeatable. So we really needed as a way to inject threat intel into the process in a more structured way. So if you're looking at threat intel reports at the time, it was very hard to do that. You would look at one report and it was a really good digest on one particular group, but it was hard to sort of look at what the common behavior is. So what is that one group doing that's similar to another group? Different companies would have different ways of describing things, and it was often at various different levels. So one report would say the adversary moves laterally, but wouldn't say exactly how, and that was a problem. And additional reports tend to focus just on malware, so it was sort of the forensic artifacts of something that could have happened. They would look at the capabilities of the malware and not necessarily how the adversary was actually using it during an incident. So that made it very hard. So what we ended up doing was looking across those reports, doing what we can to filter them out and talk about techniques in the abstract and working from there to figure out what a good structure is.
This sounds like a great application for a spreadsheet. So why is it not just a spreadsheet?
Well, it was in the beginning. Like any respectable security analyst, we started with Excel. So the original team that created ATT&CKcon was basically 2 threat intel analysts and 2 red teamers. And the threat intel analysts were Jim Miller-Osborne, who is here in the audience with us today, and me. And then our red teamers were Eric Sheasley, who is also here, and Brad Crawford. So the process that we went through was basically put all the red team knowledge TTPs into Excel and start organizing them and backing them up with what we knew that threat actors were actually doing from open source intelligence, from things that we've seen in previous experiences handling intrusions, and some MITRE data to help back up what we're actually categorizing here. And as we're going through this process, we used the Excel spreadsheet tabs. Each tab was basically an individual tactic. So we'd have a tab for lateral movement, a tab for privilege escalation, a tab for persistence. And it was helpful to organize the data in that way because we can have the technique name. We can start organizing information like what version of the operating system it worked on, what did the adversary get as a result of doing it. If it was privilege escalation, what was the effective permissions after that? Ideas for defense, so what data sources to collect, how to look at the data, and those sorts of things. And as we were going through this process, in the fall of 2013, I was asked to present to senior MITRE leadership on the progress of the FMX research with another colleague of mine, Willie Cooper-Sandin. And through the course of arduous multiple iterations on these slides, I came up with the idea that maybe we should pull out all this data that we were collecting for adversary TTPs and just bring it to the top level, describe the technique name, and then overlay what was actually being done in FMX to detect those techniques. So we had a color for particular data sources and showed like a red color for the gaps of what we couldn't detect at the time. And that was sort of a really pivotal moment for us because we were able to distill out very complex technical information, bring it up to a level that made sense for the senior leadership at MITRE so that they could understand what the security posture was, where to invest resources, And it really increased their confidence in the security program as a result. And ever since then, we've been using this sort of idea that we could take adversary TTPs, relate it to defensive information, and that helped people understand really what we were trying to do in FMX, and also the value that thinking about their defenses in terms of attack and adversary behaviors was really a good moment for us.
So you've mentioned a number of times this FMX research project. So it really sounds like FMX and an attack evolved together?
Yes, very much so. And it was sort of a chicken and the egg moment. Even though FMX came first, attack ended up driving it largely as things evolved over time. And internally, we were using attack as it was being developed to create these adversary simulation scenarios based on real threat data, so that we could show, like, no kidding, like, this really matters. A lot of the issues that we were running into early in the days of FMX was, okay, so the red team is using these behaviors, but how does this behavior actually relate to threats that I care about? And as we were starting to include the threat intel into it, it was easy to make that connection that APT3 uses these techniques that the red team is actually injecting into the FMX environment, and showing that we're actually making progress to improve detection.
So when I go around and talk about attack, one of the questions that I get, and you probably get as well, is, maybe some of you have, is, why did you make this information public? And sometimes, it's treated as almost a controversial thing. What was the thought process behind it? Was it controversial to take all this information and release it?
Yeah, it was. And a lot of our motivation was because there wasn't really a good taxonomy at the time of how to describe adversary behavior. And I mentioned the reporting aspects earlier, but that was a big moment. So if we can consolidate and talk about TTPs in a way that's consistent across multiple reports of various actor groups, that's really powerful. And attack really filled a good gap there. And if you consider a lot of the adversary life cycles that have been developed over time, they talk about high-level process the adversary goes through to accomplish their objectives, but it's really generalized. It doesn't describe operational actions that the adversary is going through in a way that defenders can think and reason about what they can actually do about it. And as you mentioned, it was sort of controversial. We get asked a lot, like, okay, so you release this out there, it's sort of the adversary's playbook. Doesn't it also help the adversary sort of learn and adapt? And I think there is a little bit of benefit there, but it is very outweighed for the defender to have the information organized in this way, because they can better understand sort of what they're up against by looking at the adversary's playbook. And at the end of the day, we're not releasing anything that isn't already public. We're backing everything with threat intelligence that's already known out there, a lot of technical information about techniques and how they're done. So any good adversary is probably already going to know most of what's in attack. And for particular adversary groups might have really good OPSEC already, so they're already aware of what's out there, and we're just sort of describing it in a different way that helps the defender a lot more.
Okay, so May 2015, attack publicly released. When did it start to really take off?
So I think it was a slow growth over time. And when we released the website, we created a Twitter account. And that was a very helpful way, as John mentioned, Twitter is awesome for InfoSec, for us to keep ingrained in the community, see what's going on, see what people are talking about with attack, and actually engage with them in real time. And that was incredibly helpful. About a year after we released attack, we published a really big update to it that included a lot more content, new ways of describing groups and software so that it was easier to see sort of the overlap of techniques, better ways of describing the data sources that you could use to detect techniques, so people were able to interact with the attack information a lot more. And then also in the summer of 2016, we started seeing presentations on attack, but this time not from MITRE. So at pretty big conferences too, like DerbyCon and BrewCon, that focused on adversary simulation and how to actually apply attack. But of course, this time it's not MITRE saying that attack's a good thing. It's other people in the community actually showing the benefit that they're seeing from using it in their own internal security and how it could improve others over time.
Which is really the theme and purpose of this conference. So you've talked about how ATT&CK was starting to get additional adoption. Maybe you could describe the changes that have been made to ATT&CK that helped that adoption?
Yep, yeah. And the original ATT&CK was based on Windows systems. There's a lot of information out there on incidents against Windows systems, but that's not all there is out there. So we released an update to include Mac and Linux. We've also expanded ATT&CK to mobile systems, so Android and iOS. And of course, if you're going to talk about post-compromise adversary behavior, you have to do something before the adversary gets access to the network. So we compiled pre-attack to help in that area as well. And as attack has improved over time, a lot of the contributions that we've been getting have been incredibly helpful too, because oftentimes people will submit a technique and work with us to get it included, and then they'll do blog posts about it, they'll talk about it at conferences, and that helps to increase awareness and adoption of attack as well.
Yeah, which is a really important point, that we do, attack benefits a lot from the community contributions that we get. It's really, I think, part of the strength of the framework. So we've been sort of looking to the past. So now if we shift gears and look to the future, what's coming next for attack? What should people be looking forward to?
Yep. So
and helping us with.
Yes. Yeah. So first and foremost, we're working on expansions to attack, looking at just basic knowledge curation, trying to keep it up to date with what threats are actually doing. And we're looking to apply a similar modeling methodology to other domains. So we're looking at network devices, we're looking at control systems, we're looking at cloud as useful ways to expand attack into other domains that people are concerned about. We're also looking at how to incorporate destructive attacks through impacts and effects, so much more beyond just exfiltration, but to include incidents like Sony Pictures, WannaCry, and things like that. We're also looking at better ways to include more technical information and variations of techniques through a concept that we're developing called sub-techniques. And this is largely driven by sometimes people look at the attack matrix and think that's all there is, and that's just not the case. People really need to dive down into the individual techniques, understand how they can be used and the variations on how they can be used. So we want to provide more details around that so that people can develop detections against multiple variations of the technique and not just have one detection for a technique and think that they're done and color their cell green.
Okay, so you just described structural changes to the framework itself. What about the larger ecosystem?
Yeah, so MITRE recently embarked on sort of a new thing for us. So we're using attack-based scenarios to do evaluations of vendor products. And largely our goals with this is efficacy-based. So a lot of vendors in the community have started to use attack, adopt it, and map their detections to it. And customers are often asking them, so what's your coverage? How can we verify this? And so they're looking for a neutral third party to basically do that assessment and show how well they cover attack. And we're currently sort of in the thick of finalizing our evals for the first cohort. We're looking to have those results published sometime next month. And we're really hopeful that both the community and the vendors themselves find the data that we're collecting valuable, as well as the process to help improve products over time.
All right, so that's near term. What about 5 years from now? Where, if you had a crystal ball, where do you see attack in this community being in 5 years?
Yeah, I think the first one is probably in the threat intel area. And we've seen a lot of organizations out there who are starting to map attack to threat intel. And I think that's great, but I think there's also a lot of room to grow there. So I think if we can get to the point where information on incidents is shared in more real time, so think of attack observables shared in a more structured fashion, a lot more faster than finished intel reports come out, will be very important, because then we can move attack from just sort of that finished intel viewpoint into what's actually going on today. And we can answer questions like, what is the most popular technique that adversaries are using today, and use that information to help inform what people should care about for their defenses. And I think the second aspect of it is sort of a change in attack itself. So MITRE has been running attack for a long time, sort of curating it as we go along, but it's important to include the community in this, especially when we're looking at other technology domains like cloud and ICS. MITRE has a lot of expertise in this area, but we don't have it all. And we certainly don't have the data to help back up to show that adversaries are actually using techniques against these technologies. So we want to be able to include other people who have that expertise and that knowledge and that data to have a say in attack and how it evolves over time.
Thank you. So those of you in McLean, you now have an opportunity to ask questions of attack team lead and teen heartthrob Blake Strom. So if you want to ask a question, we have the throw mic, or you can come up to the mic while people are getting up the courage to finally talk to Blake Strom. I'll start one off, but you will have to ask questions. Did you ever imagine that attack would become such a big deal like it is today?
No, I didn't. I thought we were going to release this thing, and some people were going to think it's cool, and maybe a few people would use it, and sort of we would move on to the next thing after that. I never really imagined that it would get this big and sort of be sort of the spreadsheet that changed an industry.
And you can't actually go to the mall anymore, right?
I can still go to the
Okay. Sunil.
Hey, Blake. Whoa. So in the way you described the future of attack, it actually sounded like the future of CAR. And we've talked many times about how CAR is really, I think, the core of what the benefit is for having attack. John Lambert mentioned it earlier, and that the detection logic, or the thing that he thought was interesting about Sigma, is really what we see in CAR. Should not we be looking at CAR as the core of what this conference is about, and sharing analytic techniques rather than just what to look for?
And for those of you who are not familiar with CAR is the Cyber Analytics Repository, and we have a bunch of things we're going to be talking about and announcing with respect to CAR over the next few months. If you had anything to add?
Yeah, I agree. That's another big area that needs to be addressed. So how to share more effective information on how to counter threats. And I think there's still a lot of hesitation for open sharing in that area, just because there's some risk at telling the world how you're actually detecting threats. So I think in closed communities, these concepts are being developed, and CAR was a great start for us to get a baseline set of analytics out there. But there's still, of course, more work that MITRE can do to help that. But I think projects like Sigma are definitely in that area too.
All right.
So one of the fundamental problems people have had with implementing things like CVSS, for example, has been that there's no contextual relationship between individual artifacts that have been categorized by CVSS. In the context of attack, having individual TTPs associated with individual IOCs independent of context with one another causes difficulties when generating analytics or detection mechanisms due to the high rate of false positives generated by independent context. How would you suggest that we can address that by adding in context between attack TTPs?
Yeah, that's a really good question. So I think part of that is understanding the context around which actions can be performed. And projects like another project that I work on is called Caldera. And so we're trying to use that concept to help automate how the system actually makes decisions and chains sequences of actions together. So I think that's one piece of that. But I would also say that it's important to actually conduct and inject the adversary behavior within the environment in order to test those hypotheses and those theories. And that's really helpful in analytic development and analytic refinement over time that can help sort of lessen those false positives.
Okay, we have another question. We have a couple of minutes left for.
Can you talk a little bit about what exactly is your vision in terms of cloud? Are you visioning another matrix for the cloud? Just where are you guys going?
Yeah, so the cloud aspect is hard because there isn't a whole lot of threat intel out there on how adversaries are actually leveraging those systems. So I think the first sort of piece there is we need to get organizations to share that sort of data more readily, and that way we'll be able to create a model similar to how we've done with enterprise for cloud systems. So I think it's still a little bit too early to have something set in place, but this is something that we're looking at right now, and I'm hopeful that we'll be able to put something out shortly.
Yeah, and I would just add, I think one of the themes you're going to hear is that MITRE is serving as this convener to bring this community together, but this is about the community, and this is about leveraging your expertise and your knowledge, and really doing that globally. And so our goal is to really just be that focal point, so that if you get a group of organizations together, say, we have this kind of expertise, we have the information to help us with the cloud technology domain or some other domain, that we can come together as a community and develop that. And so that's just a theme. Don't look to us to develop everything. Hopefully people see MITRE's role as this convener to catalyze this community and bring it together. Do we have another? We have another question up here. If you could throw a microphone at this gentleman's head.
Okay. In terms of community collaboration and workflow between MITRE and the community, what would be the right flow of this collaboration? MITRE basically provide these TTPs, and vendors are gonna consume these. And for example, the severity scores of these TTPs differ between different vendors. Who is gonna have the authority to call these severities and normalize this? Because there ought to be some inconsistency between these. Is MITRE is the one that call the severity level of a specific TTP should be such and such, or different vendors call it differently, and MITRE should somehow recalibrate these things? How you resolve this ambiguity like this?
Yeah, so I think there's a couple things there. I think depending on the technique, you can take something like credential dumping, for instance. There's specific ways on how that's done. You shouldn't really see it in your environment, and it's really easy to say that this is bad. But largely, a lot of the behavior that is categorized in attack is things that just can normally be done on a system. So it's kind of hard to take that and assign a severity score from at least MITRE's perspective, because I think a lot of it depends on the end user environment, not necessarily the vendor, not necessarily us in categorizing the TTPs, but what is normal within that environment. And so things like machine learning could probably help there, where you can sort of get a baseline of what is normal in order to figure out what is abnormal and then work from there. But I don't really see it as something that MITRE can necessarily help with. And it's really up to the vendors to figure out what makes sense for their customers in that area.
All right, gentlemen at the microphone, you probably have the last question.
Sure. So I don't know much about CAR, and that might answer my question, but is there any movement on attack going towards a community creation of rules? And because it's really, really hard to write rules for attack. Like I've tried. A lot of them are generally difficult to get down to something that it has a low false positive rate. So it would be nice if something like Sigma was linked to an attack, or something where one vendor, one person could say, I wrote it this way, and it can be applied or made better this way.
Yeah, so I mean, our focus on attack is strictly the adversary TTPs. I would say there's a lot of other efforts out there that can help sort of address, how to detect certain things. I mean, there's the Threat Hunter playbook out there. There's several other efforts. So I think We could probably do a better job at, like John mentioned, making sure there's the connective tissue there, so that to make it easier for those organizations and those efforts to map to attack. But I don't really see it as an attack problem.
And so just one last question I'm going to throw at you. What's the craziest thing you've ever seen done with attack? I mean, that you could talk about in a.
Yeah, so Shane Steger is here in the audience. Several years ago, he created a board game called Maelstrom that was based on attack. And if you consider like Magic the Gathering for InfoSec. And it was actually a really useful tool to help people understand sort of the back and forth between the adversarial process and what defenders can do against it. And he did open source it, so it's available on GitHub. But if you're interested, check it out. It was actually a pretty cool idea that he created and ended up briefing at DEF CON a couple of years ago.
Well, thank you very much for taking the time today. Please join me in thanking Blake Strong.